Students, this is a video version of the third set of notes. It's Nature of Science, Laws, Theories, and Pseudoscience. The nature of science. Scientists are working to understand the world and the universe. They base their understanding on evidence. They communicate with each other and check each other's work through peer review. Scientific ideas are durable yet tentative. Durable meaning they have been checked for accuracy and validity over and over again, and tentative meaning always subject to change if new, more accurate information is proven. Scientific laws. A scientific law is a description of an observed phenomenon. It is a statement based on empirical data, observation, and experimentation. It is usually limited to a certain set of circumstances. Often they involve an equation, and they're subject to change with new evidence. Examples of scientific laws: Newton's three laws of motion, including the second law, which is an equation, force equals mass times acceleration, the universal law of gravitation, Kepler's laws of planetary motion, Hubble's law of cosmic expansion, and the laws of thermodynamics. These are examples of scientific laws. And laws are different than theories. Scientific theories are explanations of observed phenomenon, usually a statement that can be tested, usually cannot be reduced to an equation, and subject to change with new evidence. Scientific theories are usually broader ideas. The term theory in science does describe a concept that has been thoroughly tested. Examples of scientific theories are evolution, natural selection, relativity, continental drift, and the Big Bang Theory. Pseudoscience. A pseudoscience is a collection of beliefs or practices mistakenly regarded as being based on the scientific method. Often as very interesting topics, but they don't hold up to peer review, independent research, or any kind of scrutiny. Pseudoscience examples are eugenics, Bigfoot, ancient aliens, vaccines are bad, the Loch Ness Monster, flat earth, and phrenology. Phrenology was a pseudoscience about 100 years ago where people thought you could tell somebody's behavior from the shape of their head. And it was pseudoscience, fake science. We'll take a little bit closer look at one example of pseudoscience. That's the flat Earth theory. People who believe in flat Earth theory think the Earth is flat because A, it looks flat from a person's perspective. B, all NASA photos are photoshopped. C, because their friend did an experiment with a laser pointer. And D, the government wants to trick us. Flat Earth theory is fairly easily debunkable, meaning you can argue against it and prove it to be false. For one, ships disappear over the horizon bottom first. So if you're at the seashore and the sailboat is sailing away from you, it doesn't fall off the edge of the Earth. It just goes around a curve that you can't see. Time zones and sunrise/sunset. So if you call someone in California just after sunset in Richmond, it'll be 3 hours earlier on the West Coast, and the sun will still be out there because the Earth is a sphere and it's spinning. Half of the Earth is always dark, half of it's always light, and we experience that as sunrise and sunset and night and day. There is lots of photographic and video evidence. Also, because the Earth is a sphere, the stars move a certain way across the night sky, and you can see this long exposure photograph at the bottom where the camera lens is left open for a long time. The stars go in kind of a spiral formation around the center, which is the North Star, which is directly above the North Pole. And if you were in the southern hemisphere, you see completely different stars than we see in the northern hemisphere. If the Earth were flat, you could see the Eiffel Tower from Richmond with a halfway decent telescope. Spoiler alert, you can't. Another reason why flat Earth theory is easily debunked is that every solar eclipse has been accurately predicted through the year 3000. If you recall, a couple years ago there was a solar eclipse that you could see in Virginia in August, and it was predicted by astronomers exactly what time and date it would occur. That's only possible because of the movement of the Earth and the Sun and the Moon together as celestial orbs. Probably the most important thing about pseudoscience is that if there was reliable, valid, repeatable evidence to support it, the scientific community would accept it. All scientific knowledge is durable, yet tentative. Tentative meaning subject to change with new evidence. So some examples of when science was subject to change. The giant squid. People used to think the giant squid was a fairy tale until an actual specimen was found washed ashore. It now has a scientific name, and it's a real species, Architeuthis dux, the official scientific name for the giant squid, which was a once mythical creature. Everyone thought Alfred Wegener was crazy when he first came up with the idea of continental drift. Turns out he was right, and now it's an accepted theory. Same with Darwin. His ideas were considered sacrilegious, and even to some extent by Darwin himself. But over time, more and more evidence came to support his theory, and now it's accepted. So scientists create new knowledge in this way. Scientists think of new questions to answer. They find the answers to the questions by collecting data under controlled conditions, and they manipulate particular variables while keeping other variables constant. There's two types of data a scientist might collect, quantitative and qualitative. Anything with numbers is quantitative, and anything with no numbers is qualitative. And there's some examples here. An example of quantitative data would be that there are 20 students in the room. An example of a qualitative piece of data would be that Steve is wearing a yellow shirt. So no numbers there. That's it for this slideshow. Have a nice day.